This is practice problem 5.8. I've got a graph here that shows a normal curve that approximates the slapshot speeds of NHL players in miles per hour. For part A, I want to use the graph to find the mean, standard deviation, and quartiles of slapshot speed. So I'm going to copy this over onto another slide and give myself some more room to work. First, to find the mean is where the peak of our curve is, so that's going to be about here, and if I go down, looks like that's about there on my axis, so my mean, x bar, is about 74.5 miles per hour. It's just a little bit less than 75 there. Next, to find the standard deviation, we want to look for the point on the curve where it changes from getting steeper to flattening out. So I'm going to start at the peak here and trace my way down. I'm going to look for the point, which looks like it's about here, where I go from getting steeper as I go down to starting to flatten out. And that is at about 90 miles per hour, so my standard deviation S is going to be the difference between that point, which is 90 miles per hour, and my mean of 74.5, and that is equal to 15.5 miles per hour, so that's my standard deviation. Next, to find the quartiles are the points 2/3 of a standard deviation away from the mean. So my first quartile, Q1, is going to be 2/3 of a standard deviation to the left, so I will take my mean, 74.5, and subtract 2/3 of the standard deviation, 15.5, and that will give me 64.2 miles per hour as my first quartile. For Q3, I'm looking for the point 2/3 of a standard deviation to the right, so that will be 74.5 plus 2/3 of 15.5, and that will give me 84.8 miles per hour as my third quartile. Alright, so that finishes up part A. For part B, I want to find the range of the slapshot speeds of the middle 50% of NHL players, and remember that the middle 50% falls between the two quartiles, so this will be from the first quartile, which was 64.2 miles per hour, to the third quartile, which was 84.8 miles per hour. So that's part B. For part C, where does Zdeno Chara's record slapshot fall on the graph, and why would you expect that to be the case? Alright, well, his record slapshot was 108.8 miles per hour, which is about here on my graph. So that is the record, that is the fastest slapshot ever recorded. And it looks like from my curve, maybe I could have other players up here who had faster slapshots, but we know that this curve is actually just an approximation of the distribution, so it makes sense that maybe the curve keeps going out a little bit further after my record speed slapshot.